Unit 13, Part 5. Okay, we just looked at the ill-tempered rhinos. That was an example of a complex predicate. Now we're going to look at some examples of compound subjects, not just complex subjects, not just the noun with modifiers, like students who study, right? That was complex subject. You've got a subject where we're symbolizing a couple of propositional functions to get it. This is compound subject. You've actually got two different subjects, right? So equivalent of singular sentence would be Dan and Bruce are Australian, right? So compound subjects, you've got a couple of different subjects, right? So here's an example. Cats and dogs make good pets, right? Think for a little bit about how to symbolize that. You try it and press pause and then come back. Welcome back. All right. Cats and dogs make good pets, right? It's universal inclusion, right? Cats and dogs make good pets. I'm saying all cats and dogs. I'm saying cats and dogs make good pets. Here is my first attempt, which will prove to be wrong, and might have been what you wrote down, to give the logical form of this sentence. Okay, cats and dogs make good pets. For all x, okay, it's universal inclusion. Let me lay down the form first. Let's just say px is good pets, right? You might have gx and px, but let's not worry about that for now. Cats and dogs make good pets, right? So that's the subject. Surely it's this, right? Cx and is dot dx, right? Sorry, this is it's supposed to be cx, right? Is that terrible? Okay. Have I got the correct answer? How do I determine that? Well, I read back this symbolization, literally, right? Symbol for symbol, translating it back and see if what I get is logically equivalent to the original sentence. If it is not, I've made a mistake. What does this say? Got to learn to read these. For all x, if, yes, I go from the quantifier to the major operator of the thing. For all x, if, okay, can you do this bit? Press pause and see if you can read this in a way that reveals the mistake of this categorization, and then unpause. Welcome back. For all x, right, it says, if, so remember, the x, right, all these x's refer back to that one x, right? For every single x, if that x is both a cat and a dog, then that x makes a good pet, right? What does this say? This says all cat dogs make good pets. All things that are both cats and dogs make good pets. That's what it says, right? That's how you got to read this. For all x, if it is both a cat and a dog, it makes a good pet. Klenk's hilarious joke. That's probably true. Because if I had a cat dog, that would be a pretty damn cool pet. But that is not logically equivalent to the original sentence. That's not what I mean when I say cats and dogs make good pets, right? I'm saying cats make good pets and dogs make good pets. Just normal cats that are not also dogs. And normal dogs, which are not also cats. So that's why the correct symbolization here is with a wedge. This says, for all x, right, it's still a conditional here, but this is for all x, if x is either, the wedge, a cat or a dog. Sorry if you can't see this. If either cx or dx, then x makes a good pet, right? This says, for every single x, if x is either a cat or x is a dog, then x makes a good pet. That is the correct logical form of this sentence. Why does the English have the and if it becomes the symbolization of the or? Well, because this is logically equivalent to the sentence, or the formula for all x, if x is a dog, x makes a good pet, and for all x, if x is a cat, x makes a good pet. Okay. Notice the logical form of this thing. What is the logical form of this whole thing? It is a, is this a universal statement? No, this is a conjunction, right? Scope of this for all x goes to here, right? In the order of construction of this formula, you made this universal statement, and you made this universal statement, and in the last step of construction, you conjoined them. It's a conjunction where both conjuncts are universal statements, right? So if you had this as a premise in a proof, what rule would you use? You would simplify, and you will do proofs like this. You would simplify, and then you would have two universal statements. And then you could use universal instantiation, which you'll learn about in Unit 15. What does this say? It's a conjunction, so it says this is true, and that is true. It says dogs make good pets, and cats make good pets. For all x, if x is a dog, x makes a good pet. And it is also true that for all x, if x is a cat, x is a good pet. Okay? And that's the and that the English is capturing or expressing. Okay? Let's have another look at this other compound subject. Some cats and dogs are pedigreed. Okay, again I'm going to do, I recommend you pause and you have a go at what kind of symbolization this would be. Then come back. Welcome back. Alright, so the first attempt here, I'm going to make what seems like a plausible attempt, which is again going to be wrong, and we will grasp that it is wrong when we translate the symbols back and see what it says. Some cats and dogs are pedigreed. So some, that's going to be the existential statement, right? Let's try this. For all that, there exists an x such that